Okay, in the previous video, we worked problem 2.4-7. It was a convolution problem where we had an impulse response of e to the minus t u of t, and we found the response of that system due to 4 different inputs. I just wanted to show you that you can use Octave or MATLAB to determine the convolution of 2 signals, and in this case we'll use Octave to verify our results from that problem. So here's a script that does the convolutions. Here I've defined the impulse response. Again, it was e to the minus t times u of t. We've got these delta functions that we can use to in Octave as the unit step, and also various integrals of the unit step. So delta 1 of t is the unit step. Actually, delta 0 of t is the impulse. Delta 2 of t is actually the ramp. Of course, you can delay these by putting in, for example, t minus 2. So here, this is just defining our impulse response function, and there were 4 problems. So in part A, we just had a unit step as the input. In part B, it was e to the minus t times the unit step. Part C was e to the minus 2t times the unit step. And finally, in the last part, it was a sinusoid times the unit step. And then we calculated the 3 outputs, analytically. So here are my theoretical outputs, and I'm going to compare plots of my theoretical results to the plots I get using Octave to do the convolution. And I'm going to rely on the ctconv function here to carry out the convolution. This will do the integration for me, evaluate the convolution integral. So it's going to take each of my x functions. I loop through this 4 times. It convolves each of my x input functions with h and returns a y vector that I plot. So what you'll first see on the plotted results is the result of the Octave simulation, and then on the same graph I plot the theoretical result. So we have the 4 theoretical results. So if we've got the right theoretical result, our theoretical result should overlap our Octave result. So here's what we get when we run the script. Again, you see the ctconv result in blue from the Octave simulation, and then kind of in the orange overlapping our Octave simulation result, I've plotted the theoretical result. So let me plot that again. So bring that plot forward, and you see the blue, and then directly overlapping it is our theoretical result. So this, convolution is hard, so being able to verify our convolution result gives me a lot of confidence that I've done that correctly. You will have a lab in the future where you'll be asked to use Octave to convolve 2 signals.